our first demo for our Medicine 2025. We will get started with a framework for cohort building in R using the OMOP Common Data Model.
Great, thank you for having us. Hopefully you can see my screen with the presentation.
It's loading, but yes, we can see it.
Perfect. Yeah, thank you for having us both. So we're here to talk about an R package called CohortConstructor, which is specifically for healthcare data that's been mapped to the OMOP Common Data Model. And I'm just going to give a little bit of background to the package and what the data we're working with, and then Nuria will take over and explain how the package itself works. Okay, just to say, I've put a link in the meeting chat with these slides. We also have a GitHub with the quarter you'll be seeing today and a link to this presentation. So as we go, the code you'll see in the quarter, you should be able to run that locally. You might have to download and install some packages, which might take a few minutes, but otherwise, we're going to be using synthetic data throughout. So you'll be able to download that and then run the code. So we're going to be talking about an R package that works with healthcare data and specifically data that's been mapped to a common data model. So just to give a little bit of background about that to start with. So normally, if people have been working with electronic medical records before, your life will look a little bit like this. You'll have data in some source system that wasn't collected for the purposes of research. And your job will normally be going to turn it into reliable evidence. And there'll be some long path to get there. And that will include things like data transformations to make the data ready for use, and then applying things like statistical methods. And you normally, as a researcher, are expected often to be able to do all of that. So what we use is a common data model, and for this, we're standardizing healthcare data. So we're splitting that process into two. The first part of the process is turning source data into research-ready data, so getting it into this common data model. And then as the person doing the analysis, you can then query that common data model to generate reliable evidence. One big benefit of this is that different source systems can be converted to the same common data model, so that you can use the same pipelines against different databases that have been mapped to this common standard. So the common standard we use is called the OMOP Common Data Model, so we'll be calling it the OMOP CDM throughout. This is a schematic of what it looks like, and at its core is the person table. So this represents each person in your healthcare data appears in this table with a unique identifier and some demographic information such as their date of birth. And then we have other tables that link to that. So for example, you have an observation period table that tells you when the span of time when somebody was in the data. So maybe they were in your database from 2005 to 2015. And when you're doing a study, that's the time period where they could potentially have a health event and appear in your data. We then have other tables such as condition occurrence, where we'll see things like people's diagnoses when they go and see the doctor, and also a drug exposure table, where we'll see drug dispensations to individuals. Aside from these tables that have the person information about patients, there's also these vocabulary tables. These are the tables that we use to map from source data to standard data. So if people are familiar with healthcare data, that would, for example, include a mapping from ICD-10 codes to SNOMED codes, so that all the different databases, data sources, regardless of what source coding vocabulary they used, they all end up to be using the same. So that when we do our study with multiple databases, we can use the same codes to identify patients. And really, what we're often doing in these network studies, so this allows us to run international network studies, studies within a certain country where we've got multiple data partners, all independently mapping their data to the OMOP Common Data Model. But because they've mapped to this common standard with common vocabularies, they're able to take the same code that's given to them, run that locally in their environment, and then send back aggregated results. One big benefit of that for us, especially working in Europe, is that there's no need to share patient data. So patient data stays where it is, protected behind a firewall. Analytic code gets sent out to different data partners, and those data partners run that code in their environment against their particular database management system that has the OMOP Common Data Model, and then return results that are just aggregated results, so things like median age of a cohort, which can then be combined from the different data partners. This allows you to do large international network studies where you can estimate the prevalence of a disease in multiple countries and so on. So that's the background to the common data model we're working with. I just wanted to also provide a bit of background to the tools we use. So we're using a very kind of tidyverse style-esque approach. And like I mentioned, we're working with multiple data partners who might be using multiple different database management systems. So the way we deal with that is we rely heavily on dplyr and dbplyr. So dbplyr is the database implementation of dplyr. So if we look at this example, we load the packages we need to start with, we connect to a database, and here we're just going to copy this NYC flights data set into DuckDB, just to see what this will look like. We create a small reference that includes just those two of the tables, planes and flights. And from that, we can start working with multiple databases, multiple tables in a database. So if people are familiar with a package called DM, this will look kind of familiar. We've got a single reference to a database that contains all the different tables. So here, for example, we can see the planes table, and then we can also see another table in the database that has flights information. And once we have that reference set up, we can start doing, using familiar dplyr code, but behind the scenes it's going to be working with data in our database. So here we're looking at delayed flights. We select some variables, we do a join to another table, and we're going to get a resulting data set. And just to show what's going on behind the scenes, we can use show query from dbplyr, and you can see that we've got a dplyr like pipeline that's being translated into SQL that we can then run. The big advantage of this is that it will work on different database platforms. So this same code would work on Postgres, it would work on SQL Server, it would work on Spark Databricks, which means that when we come to our package later, it can support data in all those different database management systems. So that's kind of a general example of working with data sets. Here we're going to work with the OMOP Common Data Model that I mentioned before. So we're going to create this reference to the data. And what we have here is we're going to load a few more packages. A key package now is going to be called CDM Connector. This is our package that works with all the OMOP data sets. We're going to download a synthetic data set that we'll use throughout this presentation called Eunomia. And what we're going to do is we're going to use that with DuckDB. So this Eunomia data is in DuckDB. And we're going to create what we're going to call a CDM reference. So we point to our database connection. We say where the OMOP CDM tables kept, in this case in main. Where we can write tables, again, because we're using DuckDB, this is going to be main again. And then we're going to also specify a write prefix, which will be whenever we create a table, they're always going to start with that. That just helps if there's multiple users working with the database, everyone can prefix their tables differently. And what we end up with is a reference to our whole OMOP CDM from R. So we can see we've got a reference to the OMOP CDM. We've got things like our person observation period tables that I mentioned before, and all those other tables that contain all the healthcare data people might have, along with the vocabulary tables. We've also got some other potential tables we can add. One, which are cohort tables, which we'll hear about later from Nuria. And yeah, so just to mention, when you run this line of code to get the Nuria data set, that's going to download some example data. So that might take a minute or two. But with that, you'll be able to run all the rest of the examples from today. And what does that look like? So we've got, again, a single reference. We can do CDM and then $person. That will give us our person table. And we can see what that looks like. So like I said, we've got a unique identifier for each individual in the data. They've got things like year, month, day of birth. Sometimes we'll have ethnicity concepts for individuals. We'll have things like their location. And then we can start, once we've got this reference, we can start using dplyr code. So familiar code like tally, we can just see how many individuals we have in our data set. So in our synthetic data, we've got a little over 2,500 people. We've also got the vocabulary tables, like I mentioned. The kind of key one probably is the concept table. So every concept that can represent a health event has a concept ID, like a unique code to identify that concept, and then a name. So we've got this first concept ID that corresponds to gastrointestinal hemorrhage unspecified. That's from ICD-10. And we've got thousands upon thousands of potential codes we could use. In our synthetic data, it's a small subset of the full vocabularies, but in the full vocabularies, we'd have, I think, a few million concepts from all the different vocabularies used for healthcare data, some of which are standard. So these are the ones we can use for network studies. Some of the ones are non-standard that get mapped to the standard concepts. Just to mention, we've made many different R packages that work with this format of data. I think last count there was like maybe 18 packages, something like this. It's getting a bit out of control, but we've made lots of packages that work with them. One other that's kind of a precursor to using CohortConstructor is called CodeList Generator. This helps us find which codes we want to use for a certain study, a certain phenotype or a certain condition or drug cohort we want to identify. And just to show that in this example, we can use a function called get drug ingredient codes from CodeList Generator. And what this will do is give us all the different drug ingredients that could appear for individuals and all the different codes that could represent them. Here we're using synthetic data, but in reality, when we work with real data, these code lists would be much, much bigger and we'd have many more drug ingredients that could be used. But those can then be fed into the definitions of cohorts we create. Okay, and now I'll hand over to Nuria to talk more about the package we're here to talk about today.
Yeah, well, before going over to CohortConstructor, I'm gonna start by explaining a bit how cohorts are defined when we work with OMOP. So the definition is a cohort is a set of persons who satisfy one or more inclusion criteria for a duration of time, which means that a cohort is not only defined by a set of clinical codes, but it also has to have a specific logic that define how people in the cohort will be included, will enter and exit the cohort. But also when we work with OMOP, we don't distinguish between inclusion and exclusion criteria, because all criteria can be formulated as inclusion. So we only use inclusion criteria. Also, a particularity is that individuals can contribute multiple times in a cohort, but these contributing periods cannot overlap. So basically, a subject has to leave the cohort before he contributes again into it. And finally, in OMOP, individuals can only contribute to a cohort while they are in observation in the database. So basically, it's while they are in the observation period table that Ed mentioned before. Otherwise, they cannot be in a cohort. So this is like kind of the theoretical definition of cohorts in OMOP, but how do we see them when we work in R? So basically, the OMOP generics package has a class cohort table, which defines how a cohort is in R. And this class is the one that we use in CohortConstructor, but also in many other analytical packages for OMOP. And basically, as defined by this class, a cohort must have at least 4 columns that cannot have any missingness. And these are the cohort definition ID, which identifies each cohort in a cohort table, because in a cohort table, you can have multiple cohorts. Then we have the subject ID, which is a unique patient identifier. And then the cohort start date and cohort end date, which for each record of the subject in the cohort tells you when the person enters and exits the cohort. So this is how we will see a typical cohort in R when working with OMOP. And these are the 4 base columns, but they can have more columns. For instance, there could be a 5th column stating the region of each person or something like that. But that's not all, because like cohort objects has different attributes that help the user work with cohorts. And the first attribute is the settings, which relates each cohort definition ID with the name and other variables. As you can see in the slide, this is very useful because the cohort definition ID is just a number, so it's easy to forget what ID1 contains. But thanks to the settings, you can see that in this example, cohort ID1 refers to a cohort of viral pharyngitis, and the ID2 to viral sinusitis. Then we have the attrition, which basically stores information on each of the inclusion criteria applied to create the cohort, and also how many records and subjects were kept after this inclusion. So here we have the inclusion criteria for the first cohort in these first 6 rows, and we can see each of the inclusions. So first, all the records of viral pharyngitis. Then we select only those that has a start before an end. Those that are in observation, because these are one of the rules when working with cohorts in OMOP. Then we kept only those that people contributing to the cohort had a record of sex and year of birth. And finally, if 2 records were overlapping, we merge them. And the same is done for the second cohort in the table. Another attribute is the cohort count, which basically tells you how many records and subjects are in each of the cohorts. And finally, we have the cohort code list, which tells you which were the concepts IDs that were used to create each of the cohorts. And in this case, the code list for each cohort used contain only one concept. So now that we know how a cohort is seen in R and in OMOP, we can go over how to construct them using the CohortConstructor package. And basically, this package aims to provide and support cohort building pipelines in R when working with OMOP data. The code is publicly available in the Odyssey GitHub repository. And at the moment, version 0.4 is available in CRAN. So when we want to construct cohorts, there are 2 basic steps. The first one is to create a base cohort. A base cohort is basically that uses only clinical concepts. For instance, all occurrences of asthma codes in the database, or can also be defined based on demographics. For instance, if you want all females in your database from the moment they are more than 18. And the second step, once you have this base cohort, is to curate it. So basically, it's applying inclusion criteria so the cohort is ready for your study and research. And to do this, we have a lot of functions that can be categorized into 4 sets. So first, we have functions to construct these base cohorts. But then we have functions to apply requirements and filter those cohorts. functions to update cohort entry and exit, and finally, functions for cohort transformation and combination. So I'm gonna go now through the functions that we can see in each of these categories, showing some examples. And we'll start with the base cohorts, which basically it's 4 functions. The demographic cohorts, which is to create base cohort based on demographics. Then we have concept cohort and measurement cohort, which are functions to create cohorts based on pure code list. So for concept cohort, you will introduce a code list and you will create a cohort based on the occurrences of those codes. While for the measurement cohort, you will have a code list, but you can of measurements, and you require a measurement result. For instance, you can create a cohort of BMA measurements that have a value within a certain numerical range. And finally, in this category, we also have the depth cohort, which creates a cohort based on all your depth in the database. So as an example, we're going to create a demographics cohort. In this case, we'll have one cohort table that will contain 2 cohorts, one of females and another of males, and both will be people aged 18 to 60 years old with at least 1 year of previous observation in the database. And in this case, we can create it with only this function, the demographic cohorts. And inputs that we must pass is, first of all, the CDM reference that it showed us before. So basically, this reference, it is a reference to all the OMOP tables. Then the age range that you want your cohort to have, the sex of the 2 cohorts that we will be creating, and the minimum prior observation that we are requiring. And then we have this name argument, because this will be creating a permanent table in our database in the server. So this is the name that this cohort table will have. So this is how we create this cohort, and then we can access the settings of this cohort object. And we can see how it has 2 cohorts, one with females and the other with males, both people aged 18 to 60 years with at least 1 year of previous observation. These are the cohort counts, so we can see number of records and subjects, and this is the attrition. And now I'm gonna show the attrition, but a bit nicer. So using the cohort characteristics package, we can show this attrition in this nice flow diagram. So you can see for demographics 1 cohort, which is the females one, people who satisfy the initial criteria, which is everyone in the database. Then we apply the sex requirement, and we exclude almost half of the database. Then we apply the age requirement for this mock data. This doesn't exclude anyone. And the same with the prior observation. And similar for the male cohort. And also using this package, the cohort characteristics, we can also represent the attrition in this table. And from now on, I'm gonna use these formatted tables to show the attritions. So now let's go to another example where we will create a base cohort, in this case based on concepts, and we will create 1 cohort table that contains 2 cohorts, one with diclofenac occurrences and another with acetaminophen. And first of all, here we have to use the code list generator package that was also introduced before by Ed. And in this case, we use the get drug ingredients code to get the code list for diclofenac and acetaminophen. And in these drug codes, we have a list for each of them. And the second step is basically to use concept cohort, where again, we have to pass the CDM reference, then these code lists containing acetaminophen and diclofenac, and finally, the name that we want this table to have. And if we look at the reference, at the settings of this cohort, we can see how there are 2 cohorts, one of acetaminophen and the other of diclofenac. same as before, we have an attrition on how the cohort was created. It's similar as the example that we said before, like all records, a start, before, end. In observation, the person cannot have missing sex of year of birth. And finally, in this case, as we said, there cannot be overlapping records, so we merge them. And in this case, acetaminophen, there were 297 records that had overlapped, so we merged them in the process of creating the cohort. If we, in this case, we also have the cohort code list as an attribute, which allows you to see which were the concepts used to define this cohort. And okay, now I'm going to present the first set of cohort curation functions, which are the filtering and requirement functions. So we have functions to apply requirements on demographics, which basically are age, sex, prior observation, and future observation. Then we also have functions to filter to a certain entry, for instance, the first, the last, or any entry, if you want like to get second entry to a cohort or the third one. And then we also have functions to require presence, absence, or a certain number of intersections to other cohorts, concepts, or tables in the CDM. And finally, you can require for cohort entries to happen within a certain date range, or also require a minimum number of counts for each cohort. And as an example, we are going to use this set of functions to apply inclusion criteria to the medications cohort. So we want to restrict the medications to only the first record per person, to those subjects that when they started taking the medication, they were 18 years or more, that are females, and that have at least 30 days of prior observation. So we can do that with these two functions. First, we apply requires first entry to get only the first entry of each medication. And then we apply the demographics, the age range we want, the sex, and the minimum prior observation. And if you notice in the first function, we also use the name argument. In this case, we change the name of the cohort to medication requirement because we don't want to overwrite the base cohort, which is the medications. So we are basically creating a new cohort called medication requirement, which is based on the medications cohort, but has now these inclusion criteria that we have stated. So if we look at the attritions, up until overlapping records is what we have seen before. But now, well, we are only looking at acetaminophen now. But we can see what does it imply to restrict only to the first entry. So we don't lose any subject, but we lose a lot of records because we are only getting the first one. And then when we apply the age requirement, we also lose quite a lot of people. Then the same for the sex, and we don't lose anyone for the prior observation. And for the minimum future observation, we didn't require anything. So let's go now to functions that we can use to update cohort entry and exit. Functions to update cohort exit are to set the exit date to the end of observation for that person, to the death date, or also if you have in your cohort different date columns, you can update the exit to be the first of those columns or the last one. And we have very similar functions to update entry to a cohort to the first or the last one of a set of columns. Then we have the trim functions, which basically allows you to shrink the start and end dates of a patient to meet certain demographic requirements or to be in a certain date range. And finally, we have the pad functions, which add and subtract a certain number of dates to either the start or the end. As an example here, we are going to use the trim demographics function. And what we will do is to trim the cohort start and end date of subjects so they only contribute time while they are aged 20 to 40 years old and when they have a prior observation of at least 1 year. So we pass the cohort as an input, and then we use the arguments age range and minimum prior observation to apply this trimming criteria. And same as before, we give a new name because we don't want to overwrite the base concept. And if we now look at this new attrition, we see like this is the base cohort, and these are the trimming requirements applied. If we go now through the last set of functions, these are functions to transform and combine cohorts. And we have functions to split cohorts into different years or into stratifying variables that are in our cohort. For instance, if we have an additional function, an additional column that classifies its person into an age group, you can stratify by that. Then we have functions to combine cohorts, like you can unionize different cohorts into one, or you can create a new cohort based on the intersection of other cohorts. You can filter to a certain IDs, or you can also sample to a number of people in the cohort. Then you can create a match cohort based on age and sex. We have also the collapse cohort function to concatenate entries that are within a certain number of dates. So if 2 entries are within 5 days, you can merge them into one, for instance. And finally, some utility functions to rename and copy cohorts. So as an example, we are going to create a new cohort that contains people who had an exposure to both diclofenac and acetaminophen at the same time. Basically, here we have different records of the same subject. The first two correspond to acetaminophen in blue, and the third one in orange is a diclofenac exposure. When we use the intersect cohort, what we will do is create a new cohort that contains only the intersection between these two exposures. So you will get records of when this person had an exposure to both diclofenac and acetaminophen. And basically, this can be done with the function intersect cohorts. And you can see for this new cohort intersection, the settings is now only one cohort that has both acetaminophen and diclofenac. And in this case, the cohort code list has been updated. Before diclofenac had an ID2 because it was to the second cohort, but here as this is one cohort of intersections, it all corresponds to the same ID. So this is all for the demo, but I've briefly showed the functions we have, but couldn't provide examples for everything. But we have in the package website vignettes that have more information. So if you are interested, you can have a look. And if something is not well documented, or if you have any request or find a bug, please feel free to open any issues. And also, we have not only mentioned the CohortConstructor package, but many others like CDM connector or code list generator. And if you are interested on this tidier programming when we use OMOP, Ed has written a book that is free and online available.
Yes, I can just very briefly show what that looks like. So like I was showing, we've implemented this CDM connector package that works with the OMOP Common Data Model. I think if people are familiar with dbply already, you'll see some of what's going on beneath it. If you know the package DM, that's also a more general package for working with databases and data models. In this book, we've kind of got two sections. So if you were less interested in the OMOP Common Data Model part, I think hopefully the first 4 chapters should still be interesting. So they're about how we work with R and databases. That's not specific to OMOP Common Data Model. So that's more working with dbplyr. You'll see some of the things I've mentioned today. And then in the second part, we more talk about specifically working with the OMOP Common Data Model and that CDM reference and the reference that the cohort-constructor package works with. So hopefully that would be interesting to people. We can, oh, that working. Oh, it won't let me. Oh, here we go. So for example, we can see things like I was showing with the different functions. You've got the TBL where you can reference different data tables in the database. And then this is kind of all the different ones that are working. So things like filter, arrange, mutate, and so on. And then how you can use that to get to an analytic data set. One thing we haven't really gone into too much is some of the challenges. So if we just talk about challenges of working with different databases, we can see things where, although this approach works very well generally, some things we have to take care of is when things don't always translate. So say we've got DuckDB where we can use both summarize and mutate in Postgres. To get the median, we have to be within a summarize function call. It won't work with mutate. Whereas if we go to SQL Server, it's the other way around. So that's some of the things like behind the packages to bear in mind. But if you're doing it yourself, that would, yeah, just be something to consider. And then, yeah, we've got a chapter on the cohorts, but also other things you might want to do with the OMOP Common Data Model. So you might want to be more focused on just exploring the data. So we've got a chapter on that. Let me go back to the presentation. Let me just go forward to where we were. And yes, I think we'll probably wrap up there. I know we're a bit early. We must have been nervous and spoke too quickly. Just to say at the end of this presentation, so we have shared the slides. Sorry. Oh, didn't need to press that. We have a set of exercises. It's probably not the most interactive exercise to do online, so we thought we'd leave them at the end. If you go to the GitHub, in the quarto, you have the solutions, but you could also try and do it without to start with. Hopefully, following the presentation, you will be able to. So the first exercise would be to create a cohort of aspirin use. So again, you'd have to go and find how is aspirin represented in the data. So we'd use something like codeless generator to find the different concepts that could represent it. And then we'd use cohort-constructor to put together the individuals into cohorts taking aspirin. The second would be then creating a cohort where you keep only you apply the following criteria. So you're just including the last drug exposure for each subject, so the most recent one. Only ones that start between 1960 and 1979. That's just because of the synthetic data. And then we also exclude individuals with another drug, amoxicillin, in the 7 days prior to aspirin exposure. So you can see hopefully how we can start having quite flexible examples that, depending on your research question, you can start having lots of different exclusions based on other cohorts. And then you'd end up with something that would look like this, like one of these attrition diagrams. In exercise 3, create a cohort of people taking ibuprofen. So we'll only include individuals that in the future we see to have died in our database, and we keep them in the cohort until that date of death. So we're getting a bit more challenging now, but here we'll end up with a similar attrition with these additional criteria added. And then for some practice of transformation and combination with the ibuprofen-based cohort, then create 5 separate cohorts one for each year of 1975, 76, 77, 78, 79, and 80, which are the years in our synthetic data. You might, in your reality, have more up-to-date data, hopefully. And then again, you'd end up with this attrition. And then the last cohort where users of diclofenac, females aged 16 or older, 365 days of continuous observation prior to exposure. So they've been in our data set at least a year beforehand without any prior exposure to amoxicillin. And then with the cohort exit defined as when they their first discontinuation of the exposure, but having accounted for a 7-day gap, so collapsing records less than 7 days apart. And here you'll get even more involved attrition diagram, and you'll see the impact of all the different steps. So those are the exercises that we'll leave for people to do at home. Happy to take questions. And yeah, that's, I think, everything we had to show today. So thank you for your attention. I'll stop sharing. I don't see, oh, I do see a chat actually. Oh, yes, thank you for Thomas for posting in lots of the links in the chat. I'm only seeing it for the first time. Let me just make this a bit bigger so we can read it. So there was one question. Shanushka. I don't know if you wanted to say it out loud, if you have to, or if you want me to read it. So the question was about making different cohorts for carryover / sequential treatment effects in interactions. I'm afraid I don't know exactly what that means. I don't know if you could chip in and.
Oh, what I meant was for carryover effects when you're testing out different treatments for, I think, probably the same condition. And you want to account for, well, do the patients respond differently if they get treatment A before treatment B and then treatment C versus some different order of treatments?
Okay, so yeah, yeah, I guess this package is maybe just helps you with the first part of what you want to do. So what this cohort constructor package would help you do is create all your different drug cohorts, for example. And so you might say for your research question, you might end up with 4 or 5 cohorts of people. What you'll then have is like the duration of time people are in each one and their ID and so on. When you then go on to maybe more of an analytic question, which I think is what you're doing, then you'd need to transform those cohorts yourself and prepare them for your particular analysis. To some degree, you can do like intersections with this package, but for more like modeling and statistics, that's when you'd like get your cohorts created, bring them into R perhaps, and do the analysis. I don't know if you had anything. Okay.
Thank you.
Does that answer the question?
Yeah, it did.
Perfect, thank you. I see Boris has a hand up.
Yeah, thank you so much for the presentation. I wonder, at the initial example of construction of the demographic cohort, you used criteria for selection of both males and females, and then for some reason you constructed not a single cohort, but 2 different cohorts, one for males and one for females. I just wonder whether any categorical parameter used for the construction of cohort will result in construction of different sub-cohorts, or could you clarify this topic?
Yeah, no, that's a very good question. I think Nuria, you're going to think about patient profiles.
If we go back to the example.
Oh, you're not sharing.
Oh, yeah.
Oh, sorry. it's showing the example again, right?
Yeah. So here I should have explained probably, but in sex you can you have three choices. You can put both female or male. So if we wanted one cohort with everyone, we would have put both. But when we put female and male, we are saying to the package that we want two cohorts, one of male and one of female. And we could have even put both female and male, which would have resulted in three cohorts, one stratified by sex and another with both.
Yeah, and then maybe something else to mention is, so in this case, we're making cohorts, so they're going to be, yeah, like Nuria said, both, or we've got stratification. You can also create a cohort that's everybody and add a new column with a variable that's sex and male/female. For that, we'd use a different package. We have another package called patient profiles. So the package we're showing today, CohortConstructor, is more building different cohorts, but then we've got a package called patient profiles, which would be more adding variables. So say you've got do we have a cohort table?
Yeah.
It's just before here, isn't it? So almost there. Here we go. So in this case, we've been making multiple cohorts, but we can think in some analyses, we'd want to add variables. So we could say add the age at their cohort start date. So we have a package called patient profiles. We can drop the link in the chat, which would say their age relative to the date. It could also add sex. It could also add a flag variable if they were in another cohort. So that's where it becomes, depending on what you want to do for your analysis, maybe you want one big cohort with variables added, or you want, which is where you'd use that as a package to help add them. Or you'd want multiple cohorts for stratification, which you could all do just within CohortConstructor. Hopefully that answers the question.
Thank you so much.
Great. Are there any other questions?
Yeah, I was just gonna say, not really a question, but I attended one of the big Odyssey OMOP meetings in DC a couple of years ago, and it's just really nice to have the folks on that side slowly start to give talks on the R medicine side. So it was something I was trying to pushing for the last couple of years. So thank you so much for giving your work, demo and making this happen.
Oh no, well, thank you so much. And yeah, I will put the chat to Odyssey as well. So Odyssey, just to mention for everybody, it's open source initiative. It's all focused around this OMOP Common Data Model. So it's for people working with this format of healthcare records. I think it's really taken off both in the US and in Europe, that more and more healthcare data is being mapped to this common standard. Yeah, and hopefully these R packages, quite deep layer inspired, will help make it all quite easy to start with, would be our hope. But yeah, thank you for having us. I think.
Yes, I guess we can probably call it. I know there's like another workshop or something immediately right after this, so we can give people to shift rooms if they're planning on attending other sections. But
Great, thank you. Have a good day.
thank you so much.
Bye.
Bye.